Hi Junior 6, how are you? Our lesson today called ratio. To find what the meaning of a ratio, let's tell a story. If Dua has 20 LE and Noha has 30 LE, we can compare between what they have as follows. The money with Noha is more than the money with Dua, or the money with Dua is less than the money with Noha. Dua has 20 and Noha has 30. So if I say what Noha has over what Dua has, that's equal 30 over 20 equal 3 over 2. And when I say what Dua has over what Noha has, that's equal 20 over 30 equal 2 over 3. What's the meaning of this? That's meaning for every 3 LE with Noha, there are 2 LE with Dua. Again, that's mean for every 3 LE with Noha, there are 2 LE with Dua. That means Junior 6 there are a lot of ways to comparing between what Dua has and what Noha has. From this way, the ratio. That means the ratio is a way of comparing between two quantities from the same type and the same unit by division. Again, the ratio is a way of comparing between two quantities from the same type and the same unit by division. Junior 6. All the definitions in Junior 6, this is very important because I ask you in exam by the definition. Okay? So all the definition in Junior 6, this is very important. Okay? Let's complete. Expressing the ratio. To express the ratio, I have two ways. As an example, the ratio between the two numbers 3 and 4 can be written in two ways. Number 1 as a fraction, 3 over 4. So I read it as a fraction, 3 over 4. Number 2, 3, 2, 4. These two dots, this is a sign of ratio and called 2. So I read it 3, 2, 4. 3 to 4. The first number called the first term or antecedent. Again, the first number called the first term or antecedent. And the second number called second term or consequent. So when I ask you what's the antecedent of this ratio, the answer will be 3. And when I ask you what's the consequent of this ratio, the answer will be 4. Okay? From our study before, the fraction 3 over 4 and the fraction 4 over 3. Are these two fractions equal, Junior 6? Yes, that's right. It's not equal. So, that means what? That means the ratio 3 to 4 not equal the ratio 4 to 3. That means the order in ratio is important, is very important. Properties of the ratio. Number 1, the ratio has the same properties of fraction, such as simplifying and comparison. I can express the ratio by a fraction, so I have all the properties of the fraction. What's the properties of the fraction, Junior 6? When I'm multiplying the numerator and the denominator by the same number, or dividing the numerator and the denominator by the same number, the fraction change in the shape, but in the value will be the same. Again, when multiplying or dividing the numerator and the denominator by the same number, the fraction change in the shape, but in the value will be the same. Number 2, the two terms of the ratio in its simplest form should be two whole numbers. Again, the two terms of the ratio in its simplest form should be two whole numbers. As an example, put each of the following ratios in its simplest form. Put each of the following ratios in its simplest form. Simplest form meaning I use the division operation. Simplest form, that means I will use the division operation. Number 1, 10 to 15. I need to put this ratio in simplest form. So I thought 10 and 15 divisible by what? I must divide the two terms by the same number, because I am not change the ratio. I will change the ratio in the shape only, but in the value will be the same. So I divide the two terms by the same number. So I thought 10 and 15 divisible by what? Yes, divisible by 5. So I will divide the first term and the second term by 5. So 10 divided by 5 equal 2 and 15 divided by 5 equal 3. But if I forget the timetables or I forget the divisibility, what I do? I put 10 over 15 as a fraction on a calculator. Again, I put 10 over 15 as a fraction on a calculator. And I put equal. And I get the answer, 2 over 3. Again, if I forget the timetables and the rule of divisibility, and I need to get the simplest form to this ratio, I put 10 over 15 as a fraction on a calculator and put equal. I get the answer as easy way, 2 to 3. Okay? The next example, 24 to 36. 24 to 36. Again, I thought 24 and 36 divisible by what? Yes, it's divisible by 6. So I divide the first term by 6 and the second term by 6. So 24 divides 6 equal 4 and 36 divides 6 equal 6. But 4 and 6, it's not simplest form because I can divide it by another number. 4 and 6 divisible by what? Divisible by 2. So I divide the two terms by 2. 4 divide 2 equal 2 and 6 divide 2 equal 3. And also, when I forget the table, I use the calculator. I put 24 over 36 as a fraction in a calculator and put equal. I get the simplest form in one step. Exercise number 2. Put each of the following ratios in the simplest form. But when I have a point in the ratio, as this example, 0.3 to 0.45, what I do? Can you remember? I cancelled the point by what? Can you remember junior 6? When I'm multiplying the decimal number by 10, 100 or 100 or 1000, I move the point to the right as a number of the zeros. That means when I'm multiplying by 10, I move the point one place to the right. When I'm multiplying by 100, I move the point two places on the right, to the right. Okay? So I have 0.3 and 0.45. In the first term, I have one place after the decimal point. And in the second term, I have two places after the decimal point. So I'm multiplying by 100 to cancel the point. So 0.3 times 100 equal 30, and 0.45 times 100 equal 45. Now I have two numbers, two whole numbers. What I do? I put 30 over 45 on a calculator as a fraction and put equal. I have the simplest form 2 over 3. Another example, 1.4 to 42. I have a point in one term. That means I must cancel the point by multiplying 10, 100, 1000. I have one place after the decimal point, so I need 1 0. So I'm multiplying by 10. So 1.4 times 10 equal 14, and 42 times 10 equal 420. And put it on a calculator as a fraction. 14 over 420 equal 1 over 30. This is the simplest form to this ratio. Example number C, half to 3/4. Now I have two fractions in the ratio. What I do? Can you remember crisscross, junior 6? I will do a crisscross from down to up, from down to up. So 2 over 3 and 4, 2 times 3 and 4 times 1. 4 times 1 equal 4, and 2 times 3 equal 6. Again, I have two fractions, and when I have two fractions, I will do crisscross from down to up. 4 times 1 equal 4. This is the first term. And 2 times 3 equal 6. This is the second term. Now I have two whole numbers. What I do? Yes, I put it on a calculator as a fraction. 4 over 6. And I get the simplest form 2 to 3. Follow properties of ratio. Property number 3. To compare between two quantities, they must have the same units. From the definition, the ratio is a comparing between two quantities from the same unit. So, to compare between two quantities, they must have the same unit. Property number 4. The ratio between two quantities has no units. The ratio between two quantities has no units. Okay. Let's revise what the units we studied before. Units of length. What's the unit of length, Junior 6? You can remember it? Kilometer, meter, decimeter, centimeter, millimeter. Again, kilometer, meter, decimeter, centimeter, millimeter. That's the unit from big to small. And to convert from big to small, I will be multiplying. And to compare from small to big, I will use the dividing. Again, from big to small times from small to big divide. From big to small times from small to big divide. I put the unit on your on my hand. I put the unit on my hand from the biggest figure. Kilometer, meter, decimeter, centimeter, millimeter. I have big space from kilometer and meter. This is space by 1000. Again, I have big space between kilometer and meter. This is space by 1000. And I have 3 spaces equal between my fingers. I have 3 spaces equal, 3 small spaces equal between my fingers. Each space by 10. When I convert from kilometer to meter, that means from big to small, so I use the multiply. From kilometer to meter, multiplying by 1000, from meter to decimeter, multiplying 10, and from decimeter to centimeter, multiplying by 10, and from centimeter to millimeter, multiplying by 10. And when convert from small to big, divide by the same number. So, unit of length, kilometer, meter, decimeter, centimeter, millimeter. I put it on my hand to be easy to study. So, to convert from big to small, I'm multiplying by from kilometer to meter times 1000, from meter to decimeter times 10, from decimeter to centimeter times 10, and from centimeter to millimeter times 10. Units of area. What's the unit of area, Junior 6? The unit of area, the same unit of length, but it's doubled it. So it's a kilometer square, meter square, decimeter square, centimeter square, millimeter square. So I double the unit, so I double the number of zeros. Again, units of area, kilometer square, meter square, decimeter square, centimeter square, millimeter square. That means I double the unit, so I double the number of zeros. So when convert from kilometer square to meter square, I'm multiplying 1 and 6 zeros. 1 million. Because the double of 3 zeros from kilometer to meter, I double the 3 zeros will be 6 zeros. And from meter square to decimeter square times 100, from decimeter square to centimeter square times 100, and from centimeter square to millimeter square times 100. And when convert from small to big, I divide by the same number. Unit of capacity. Unit of capacity, liter and milliliter. I have 2 units only, liter and milliliter. To convert from liter to milliliter, I'm multiplying by 1000. But I have another name to these 2 units. Liter equal cubic decimeter and milliliter equal cubic centimeter. Again, liter equal cubic decimeter and milliliter equal cubic centimeter. This is the 2 names in the same unit. Liter and cubic decimeter, these two names in the same unit. Milliliter and cubic centimeter, two names in the same unit. Units of weight. I have 3 units to weight: ton, kilogram, gram. Ton, kilogram, gram. Any convert in the weight times 1000. From big to small times and from small to big divided by the same number. Units of money. I have 2 units to money, LE and PT, pound and piasters. To convert from LE to PT, multiplying by 100, and to convert from PT to LE, divided by 100. Units of time. Years and months. Weeks and days. Days and hours. Hours and minutes and seconds. To convert from years to months, multiplying by 12, because the year equals 12 months. And to convert from weeks to days, multiplying by 7, because the week equals 7 days. And to convert from days to hours, multiplying by 24, because the day equals 24 hours. And to convert from hour to minute, times 60, and to convert from minutes to second, times 60. Units of cultivated lands. Units of cultivated lands. This is a new unit. This is a new unit for us. فدن, كيرات, سهم. فدن, كيرات, سهم. فدن equal 24 kirat, and the 1 kirat equal 24 sahm. So when I convert from fedin to kirat, time is 24, and when I convert from kirat to sahm, time is 24. And when convert from sahm to kirat, that's mean I convert from small to big divided by the same number. As an example, put each ratio in the simplest form. What's the meaning of simplest form? I will use the division operation. Number 1, I have 1.2 meter to 40 centimeter. To use the properties of the ratio, I need to put this ratio in the true definition. What's the definition of the ratio? The ratio is the comparing between two quantities from the same unit. This is the two quantities here from the same unit, Junior 6? No? So I must put it in the same unit. So what I do, I looking for a smallest unit. Looking for the smallest unit. What's the smallest unit here? Meter or centimeter? Yes, centimeter. So I keep the 40 centimeter and I convert from meter to centimeter. By multiplying. To convert from big to small, I will use the multiplying operation. So to convert from meter to centimeter, I'm multiplying by 100. So 1.2 times 100 equal 120 centimeter, and I keep 40 centimeter as the same. Again, when I have ratio between two quantities from the different unit, I must put it in the same unit. So what I do, I looking for the smallest unit. The smallest unit is a centimeter here, so I keep it the 40 centimeter as the same, and convert the next unit from meter to the centimeter. I have meter, I will change to the centimeter. From meter to centimeter, what I do? Multiplying by 100. So 1.2 times 100 equal 120. Now I have the two quantities from the same unit, but in the ratio I haven't the unit, so I cancel the unit. Centimeter by the centimeter, I cancel the unit. Now I have two numbers, so I put 120 over 40 in a calculator, and I get it in the simplest form. So 3 to 1. For example, half kilogram to 450 gram. I have here two different units, so I must put it in the same unit. What I do? I looking for the smallest unit. What the smallest unit here? Yes, it's a gram. So I keep 450 gram as the same, and convert from kilogram to gram. To convert from kilogram to gram, what I do? Multiplying by 1000. So I put half times 1000 on a calculator. I will get 500 gram, and I kept 450 gram as the same. Now I have two quantities from the same unit, but in the ratio I haven't a unit, so I cancel the unit. So now I have two numbers. So I put it in a calculator, 500 over 450. I will get the simplest form. Another example. 2 days to 8 hours. I have two quantities from the different unit. What I do, Junior 6? Yes, looking for a smallest unit. What's the smallest unit here? Yes, hours. So I keep it 8 hours, and I convert from day to hour. What I do from day to hour? Yes, multiplying by 24, or I'm multiplying by 24 times 24. So I put 2 times 24 in a calculator. So 2 days will be 48 hours, and I keep it 8 hours as the same. Now I have two quantities from the same unit, so I cancel the unit because I don't have a unit in the ratio. Now I have two numbers. What I do? I put 48 over 8 on a calculator, and we'll get a simplest form. Now I have the important ratios, is a constant ratios. Number 1, the ratio between the side lengths of equilateral triangle and its parameter. In equilateral triangle, I have three sides equal, right, Junior 6? So when I have the side equal 1 centimeter, that means the parameter equal 3 centimeter. That's right. And when I have the side 2 centimeter, the parameter equal 6 centimeter. And 2 to 6 in a simplest form, also 1 to 3. So this is the constant ratio. Constant ratio. So the ratio between the side lengths of an equilateral triangle and its parameter 1 to 3. Number 2, the ratio between the side lengths of a square and its parameter 1 to 4, because the parameter equal the 4 times from the side. So when the side equal 1, the parameter equal 4, and when the side equal 2, the parameter equal 8. And when I put 2 over 8 on a calculator, the simplest form 1 to 4. So it's the constant ratio. So the ratio between the side lengths of a square and its parameter 1 to 4. The ratio between the two side lengths of a square equal 1 to 1 because it's the same number. 1 to 1. Number 4, the ratio between the side lengths of a rhombus and its parameter 1 to 4 as a square because all the sides are equal. So the parameter is 4 times the side. The parameter equal 4 repeated 4 times from the side. So this is the constant ratio. And the ratio between the diameter length of the circle and its circumference equal 1 to pi. The ratio between the diameter length of a circle and its circumference 1 to pi. And the ratio between the radius length of the circle and its circumference 1 to 2 pi. This is a very important ratios. Study well, Junior 6. I have finished Junior 6. I hope you understood the lesson. Do the homework and follow me. Good luck and goodbye.